Ever wondered why pointers in Java are often a topic of confusion or misunderstanding? Well, we're here to clear the air. The concept of pointers can be a bit daunting for many, especially those who are new to the world of Java. You see, the term pointer conjures up images of complex memory management, a feature that is typically associated with languages like C and C++. But here's the twist. Java doesn't have explicit pointers. That's right. While other programming languages give you direct control over memory locations, Java takes a different approach. It abstracts away the complexity of memory management and replaces explicit pointers with references. This is one of the reasons why Java is celebrated for its simplicity and readability. But don't worry, we're not going to leave you hanging there. By the end of this video, you will have a better understanding of how Java handles pointers. To understand pointers in Java, we must first delve into how Java handles memory. Now, Java's memory model is comprised of two main areas, the heap and the stack. The heap is where our objects live. It's a large pool of memory where new objects are created and exist until they're no longer needed. The stack, on the other hand, is a smaller area of memory that's used for executing threads and storing primitive variables and object references. The way Java manages memory is one of its most notable features. Unlike languages like C++, Java automatically manages memory through a process called garbage collection. This means that when an object is no longer being used or referenced, Java's garbage collector steps in to automatically reclaim the memory, freeing up space on the heap. And this, friends, is a big plus, as it saves developers from the tedious task of manual memory management. Now let's bring in Java references. You might be wondering how these relate to pointers. Well, in many ways, Java references behave like pointers in other languages. They hold the address of an object in memory. However, there's a key difference. Unlike pointers in languages like C++, Java references do not allow direct access to memory addresses or provide the ability to manipulate these addresses. This abstraction is part of Java's security and robustness, ensuring that memory is properly managed and that bugs related to memory access are minimized. Yet, despite this difference, Java references do share a core similarity with pointers. They serve as a way to access objects in memory. When we create an object in Java, a reference to that object is also created. This reference, much like a pointer, is used to interact with the object, whether we're calling methods on the object or changing its state. Java uses references to control access to objects in memory, much like pointers in other languages. It's a fascinating system that balances ease of use, security, and efficiency. And as we move forward, we'll see just how crucial these references, or Java's version of pointers, are in programming. Now that we've covered the Java memory model, let's dive deeper into how Java uses references as pointers. In Java, when we create an object, a chunk of memory is allocated to it, and the reference to that object is nothing but the address of that chunk of memory. This is similar to the concept of pointers in other languages like C or C++, but with a crucial difference. Java doesn't allow direct access to memory addresses, hence we can't manipulate memory directly as we could with pointers. Let's consider a simple example. If we create two objects, say Object 1 and Object 2, and we assign Object 2 to Object 1, what we're essentially doing is copying the address of Object 2 into Object 1. Now both references point to the same memory space, and changes to Object 1 will reflect in Object 2 as well. This is where the concept of reference by sharing comes into play in Java. When we pass an object to a method, we're actually passing the reference, not the actual object. This means any changes made inside the method will affect the original object. Now let's talk about type safety. Java ensures type safety by checking at compile time that the type of the reference and the type of the object it points to are compatible. This prevents a lot of potential issues that can arise from inappropriate typecasting. Another key aspect of Java's approach to pointers is garbage collection. When an object is no longer referenced, Java's garbage collector automatically reclaims the memory, preventing memory leaks. It's important to note that while Java does not support traditional pointers, it uses references to provide similar functionality. But it does so in a more controlled and safer way, eliminating many of the issues that come with direct memory manipulation. While Java does not have explicit pointers, it uses references to achieve similar functionality in a safer and more controlled way. Let's now summarize what we've learned about pointers in Java. We embarked on this journey by understanding the memory model of Java. Java's memory is divided into two distinct areas, the stack and the heap. The stack is where the Java virtual machine, or JVM, stores reference variables, while the heap is where the objects themselves reside. We then explored the concept of references in Java. References are essentially Java's version of pointers. They hold the memory address of an object in the heap and are stored in the stack. When we say reference, we're referring to the variable that points to an object in memory, not the object itself. However, it's important to remember that Java does not have explicit pointers like some other programming languages. The decision to exclude pointers was a conscious design choice made by the creators of Java. This decision was primarily driven by two factors: safety and simplicity. Pointers can lead to complex and error-prone code, making programs harder to write, read, and debug. By eliminating explicit pointers, Java reduces the possibility of harmful errors, such as memory leaks or segmentation faults. We've also seen how Java achieves similar functionality to pointers through references. We can pass references to methods and manipulate objects in the heap, much like we would do with pointers. Yet, Java's approach ensures that we don't have direct access to the memory address, enhancing the safety and security of our code. And that's a wrap. Now you should have a clearer understanding of pointers in Java, or rather, the lack thereof. It's fascinating to see how Java has managed to provide the functionality of pointers while maintaining a high level of safety and simplicity. This knowledge should enrich your understanding of Java's inner workings and contribute to your growth as a Java programmer. Keep exploring, and remember, every line of code brings